What precisely lies at the edge of the detectable universe has stayed a secret for a really long time, filling interest and speculation among researchers and devotees alike. However, the James Webb Space Telescope holds the key to unveiling this infinite mystery. With its powerful lenses looking further into space, it has recently made a historic announcement about what lies at the edge of the discernible universe. When we discuss the edge of the universe, it's fundamental to comprehend the concept of the recognizable universe. The recognizable universe includes everything we can see, measure, and study from Earth or our space-based telescopes and exploratory probes. Currently, it comprises stars, galaxies, and other celestial objects that are within our observational reach. So, what's the difference between the universe with a capital U and the discernible universe? In simple terms, the discernible universe is just a small part of the whole universe that we can study and grasp. While the total size and shape of the entire universe are unknown, there is an estimated diameter of the discernible universe, which is around 93 billion light-years. A light-year is a unit of distance that light travels in 1 year, which is around 5.88 trillion miles or 9.46 trillion kilometers. So, the diameter of the discernible universe, 93 billion light-years, is an incredibly vast area, spanning roughly 546 million. The theory of the Big Bang tells us that around 13.8 billion years ago, the universe was born in a powerful explosion. This explosive event set off a rapid expansion, and since then, the universe has been expanding at an increasingly faster speed, driven by perplexing forces like dark energy. As the universe expanded, particles of matter began clumping together due to the force of gravity, forming inspiring structures like stars, galaxies, and eventually even planets like our beloved Earth. Over countless years, these astronomical structures became larger and more complex, leading to the remarkable variety of objects and phenomena that we observe throughout the universe today. Despite the vastness of the universe, it is predominantly empty. To put it in perspective, if we scale down our entire solar system to the size of a quarter, the nearest star would still be the distance of 2 soccer fields away. And this is just within our Milky Way galaxy, which is one among billions in the observable universe. You may ask why we can't see the entire universe. There are 2 reasons that explain this. The first reason is that light takes time to travel through space. When we look at distant objects in the universe, we are actually observing them as they were in the past. The farther away an object is, the longer its light takes to reach us. So, by observing distant galaxies, we are essentially looking back in time, unraveling the history of our universe. The second reason is the universe's expansion. Imagine specks on the surface of a swelling balloon. As the balloon expands, the specks move away from each other. The same principle applies to the universe, where galaxies are drifting apart as space itself expands. This expansion causes the light from distant objects to become stretched, shifting towards longer wavelengths, which we observe as redshift. Eventually, some objects will move beyond our observational reach as they recede past a certain distance. Considering these factors, it's not surprising that we haven't seen the entire universe. However, the concept of the edge of the universe is a fascinating topic that has intrigued scientists, philosophers, and theologians for ages. We have various theories about what lies beyond, but the truth remains elusive. However, there are 3 theories that stand out. The first theory is that the universe continues infinitely in every direction. This theory is based on the cosmological principle, which states that the universe is isotropic, meaning it looks the same in every direction. If this principle holds true, it implies that the universe extends on infinitely without a boundary. The second theory suggests that the universe is finite but doesn't have a distinct edge either. This means it's like a giant sphere, and if you keep going in any direction, you'll eventually circle back to where you started. The third theory is the multiverse hypothesis, which proposes that our universe is just one of many. Imagine a bunch of parallel universes, each with its own set of rules and properties. These universes could be vastly different from one another or somehow connected. We've discussed ideas surrounding the edge of the universe by looking at various theories. Now, let's turn our attention to a remarkable tool that holds the potential to shed light on these secrets. The James Webb Space Telescope, JWST. This incredible telescope allows us to peer far back in time and discover unexplored objects from the early stages of the universe. The JWST, with its advanced capabilities, has enabled astronomers to look back into the dawn of the universe and guess what they've stumbled upon: something astonishing. In a recent study published in the journal Nature, the JWST discovered 6 massive galaxies that existed between 500 million and 700 million years after the Big Bang. Scientists were only expecting to find small, newly formed galaxies, but the JWST caught them off guard. These galaxies are far larger than anyone ever imagined, challenging what we thought we knew about the early universe. But that's not all. Researchers also found something incredible. These galaxies are as mature as our 13-billion-year-old Milky Way galaxy. The mass of stars within each of these objects totals several billion times larger than that of our Sun. According to the research, one of these galaxies may be as much as 100 times our Sun's mass. For comparison, the Milky Way contains a mass of stars equivalent to about 60 billion suns. You see, this telescope has a unique power. It can see things that are invisible to our eyes. By using infrared light, it captures the faint glow from ancient stars and galaxies that have been around for a long time. This means the JWST can literally take us back in time, offering a glimpse of what the universe looked like around 13.5 billion years ago. Now, here's where it gets really interesting. The universe is estimated to be around 13.7 billion years old, so this discovery has turned things upside down. It's like rewriting the history books. These massive galaxies, nicknamed universe breakers, have scientists scratching their heads. They challenge most of the models we had for early galaxies. We used to think galaxies started as small clouds of stars and dust, gradually growing over time. Well, these universe breakers proved us wrong. When the Webb data and high-resolution photographs from the telescope became available in July 2022, researchers were blown away. They were shocked when they saw these galaxies as large spots of light, questioning their own understanding of the data. The sudden appearance of these giant objects, as if they wanted to be found, astonished everybody. By using spectroscopic techniques to analyze light across different wavelengths, researchers can uncover significant information about these galaxies, such as their composition, size, and distance from Earth. What's fascinating is that this groundbreaking discovery wasn't even at the top of the list of things scientists had planned with the James Webb Telescope. It exceeded all expectations and unfolded much quicker than anticipated. There's even a possibility that some of the objects found using Webb data might be something entirely different. While most are likely galaxies, there's a chance that a few could be hidden supermassive black holes. Here's the interesting part. The known mass of stars in the universe is now believed to be up to 10 times more than we previously thought. This revelation is still staggering, even if we consider just half of the sample. Meanwhile, using the powerful James Webb Space Telescope, JWST, a global team of astronomers also made a fantastic discovery. They found the oldest and farthest galaxies ever confirmed. These galaxies take us back to when the universe was just a tiny fraction of its current age, less than 400 million years after the Big Bang. The light from these galaxies reached us more than 13.4 billion years ago, as detected by the telescope. Like the early observations made by the Hubble Space Telescope, the initial images captured by the JWST revealed several potential galaxies. Now, through meticulous spectroscopic observations, astronomers have confirmed 4 of these objects, allowing them not only to study the physical properties of the galaxies, but also to accurately determine their distances. To determine a galaxy's distance, astronomers calculate its redshift. Redshift is a phenomenon where objects appear to move away from us, causing their light to stretch and shift toward longer, redder wavelengths as the universe expands. Redshift estimates can be obtained from photographs taken through different filters, but spectroscopy is the preferred method for obtaining accurate measurements, as it breaks the object's light into its constituent wavelengths. The new discoveries focus on 4 galaxies with redshifts greater than 10, meaning they're incredibly far away. The Hubble Space Telescope previously spotted 2 of these galaxies, and their redshifts were confirmed to be 10.38 and 11.58. However, the JWST images revealed 2 even more distant galaxies with redshifts of 13.10 and 12.63. Redshift 13.10 represents a time period approximately 13.5 billion years ago, unveiling ancient cosmic history. Moreover, the JWST's Advanced Deep Extragalactic Survey, JADES, is an ambitious program that has been allocated over a month of the telescope's time. Its goal is to provide an unparalleled look into the early universe. In 2015, a consortium of instrument teams proposed this project, forming an international collaboration known as JADES, involving over 80 astronomers and scientists from 10 different countries. Beginning with NIRCam, the JADES program dedicated over 10 days of mission time to observing a small area of the sky, including the Hubble Ultra Deep Field. For more than 2 decades, astronomers have been exploring this area using various large telescopes. By studying the field in 9 different infrared wavelength bands, the JADES team made an exceptional discovery: nearly 100,000 faint objects, most of which are distant galaxies. The team carefully studied 250 of these galaxies, narrowing them down to 4 with redshifts greater than 10. These 4 galaxies are incredibly compact, with sizes ranging from just 160 to 700 light-years in diameter. In contrast, the Milky Way has a diameter of 100,000 light-years. Despite their small size, these galaxies are forming new stars at astonishing rates. In one of them, stars are being born at a rate equivalent to the Milky Way's star formation, even though the Milky Way is 100 times larger. Furthermore, the distant galaxies found by JWST share similarities with galaxies in the observable universe, suggesting that galaxy formation in the early universe proceeded rapidly and followed a pattern that continues today. This remarkable finding challenges our understanding of how the universe evolved. The groundbreaking discovery made by the James Webb Space Telescope has captivated astronomers worldwide and sparked excitement about what lies beyond. With its unparalleled capabilities, JWST promises to rewrite the history of the universe and uncover more astonishing secrets from the cosmos. As we continue to explore the universe's edge and study these distant galaxies, we move closer to unraveling the mysteries of the cosmos and gaining a deeper understanding of the origin and fate of our universe.